Hi, just another retrieval practice question. The line passing through 3, 1 and negative 2, 5 is perpendicular to the line 4y is equal to 5x minus 3. We need to determine whether this statement is true or false. So first thing we can go ahead and do, we know what the equation of this line is, but we don't know this, the equation of the line going through 3, 1 and negative 2, 5. So we'll go ahead and find the gradient m, y2 minus y1 for x2 minus x1. And this is equal to 5 minus 1 over minus 2 minus 3. And it gives us minus 4 over 5. So we know the gradient. Now we can go ahead and find the equation of the line passing through these 2 points. So we have y, using this formula, we have y minus y1 is equal to m x minus x1. And this gives us y minus 1 minus 4 over 5 x minus 3. And this works out to be 5y is equal to minus 4x add 17. We can see what the gradient here is. Let's do it in standard form. Minus 4 over 5x add 17 over 5. So we know the gradient here is minus 4 over 5. Now, let's go ahead and rearrange this into standard form, and then we can see what the gradient is. So we have y is equal to 5 over 4x minus 3 over 4. So we know the gradient is 5 over 4. And we know the condition for perpendicularity is that m1 times m2 is equal to negative 1. And we can check that. m1 is minus 4 over 5 times 5 over 4, and that's equal to negative 1. So we've shown that this statement is true, that the line passing through 3, 1 and negative 2, 5 is indeed perpendicular to the line 4y equal to 4x minus 3. But what I'd like to do is to show you another approach. You might have discovered this, but sometimes we miss things, and one key element of maths is to be able to generalize any patterns or observations. So let's just rub this out to gain some more space. Now here's the generalization that will help to resolve this problem in a different way. So the equation of a line perpendicular, I'm using this symbol, perpendicular to ax at by at c equal to 0 is of the form bx minus ay at some constant k equal to 0. Notice we've swapped. We've used the coefficient of y here and made it the coefficient of x, and we use the coefficient of x here, or minus the coefficient of x here as the coefficient of y. So what we need to do is rearrange our equations in these 2 forms, and then check and see whether it does indicate that these 2 lines are perpendicular. So initially with these two coordinates we had, let's put it in this form, 5x minus 4y add 3 equal to 0. So that's concerning these 2 points, the line passing through these 2 points. And with this, we'll rearrange this line or this equation in a similar form. And that gives us minus 4x minus 5y minus 17 is equal to 0. And you can go ahead and check this for yourself. All I've done is rearranged this, move the actually I just rewrite these two equations so it becomes clearer. So first we start with 4y is equal to 5x minus 3, and this becomes 5x minus 4y add 3 equal to 0. So we just rearranged it in the form ax add by add c. And the equation passing through these 2 points, that was 5y is equal to minus 4x add 17, and this becomes minus 4x minus 5y minus 17 equal to 0. In this way it's a lot easier to compare. And remember, we have that if the line is in this form, it becomes bx minus ay at k equal to 0. So if this is perpendicular to this, then we have this change from ax by at c to bx minus ay at k. And if we look at this as the first, we have a being 5, and we can see it's switched to minus a here as a coefficient of y. We have b being negative 4 of the coefficient of y, now it becomes negative 4 as the coefficient of x. And you can verify that by looking at how the coefficient here, a changes to minus a, b just switches to the coefficient of x. And that's it. Thanks for watching this video. My name is Alistair. Practice, practice, and practice some more. Bye for now.